All right, our second trig basics video, we're going to be taking the things that we did in the first video and applying them to the unit circle. So in the first video, and if you haven't watched that yet, it might not be a good idea to, or it might not be a bad idea to go back and take a look at that. We filled out our trig table here using the special right triangles 30, 60, 90, 45, 45, 90, and SOHCAHTOA to fill out that trig table. And we also did a little talk on converting from radians to degrees or vice versa. Actually, the example we did degrees to radians. And we talked about what 30, 45, and 60 would be in terms of radian measures. So now what we're going to do is apply those ideas to the unit circle and talk about why the idea of the unit circle is so important. All right, so first of all, uh, the important thing to know about the unit circle is it is a circle with a radius of 1. And we're going to talk about all the points on the edge of the circle. So for example, this point here would be 1, 0, and then going around the circle, because it's got a radius of 1, up here we would have 0, 1, and let me just put those degree measures in as well. That would be 90 degrees, or in radians, pi over 2. This would be 0 radians, or if we went all the way around, it would also be 2 pi radians. This would be 0 degrees, or 360 degrees as well. This is the circle that I use in Algebra 2. It gets a little messy. The space gets a little tight. In Honors Math 4, we actually just use a grid and make our own circle on it. But this one I like to start with. So we're going to keep filling out our quadrantal angles going around the unit circle here. So we have 180 degrees, which we said was pi radians. And then last but not least, we have, trying to zoom out a little bit here, we have 270 degrees here, or 3 pi over 2, and that would have a value of 0, -1 as the point that's on the unit circle. So why are we so worried about these points? Well, all the points going around the unit circle, starting with these 4 that we just put there, actually give the cosine and sine values of that angle. So in other words, when we put this 1 right here, for example, what that means is the cosine of that was 0 degrees, or we could say 0 radians, is actually equal to 1. And the sine of 0 degrees is equal to 0. Okay, so it gives us these cosine and sine values of the quadrantal angles. Okay, but what's really cool is that if we actually went around and found the points going on this around the circle at all of these other angles that have 30, 45, and 60 as their reference angles, we would find all of the same trig values we just put in our table. Let's start in quadrant 1 here. So in quadrant 1, we know that all the x values are positive and all the y values are negative. So I'm just going to put here positive, oh, I'm sorry, not negative. All the values in the first quadrant are positive. I'm trying to talk and pick a color at the same time. Okay, so again, these relate to cosine and sine respectively. Okay, I'm just going to put that right here. When I write plus plus right there, what I'm saying is cosine is positive because of that guy, and sine is positive because of that guy. Tangent is sine divided by cosine. So if I'm going to take positive divided by positive, I know I'm going to get a positive. All right? I'm going to continue on with our positives and negatives going around the unit circle here. So in quadrant 2, x would be negative, y would be positive. That means that cosine is negative and sine would be positive. So that means tangent is negative because we'd be doing a positive divided by a negative. In the third quadrant, we have negative, negative. But tangent would actually be positive because sine is negative, cosine is negative, so we'd be taking a negative divided by a negative. Quadrant 4, positive, negative. Now sine divided by cosine would be a negative divided by a positive, which would be a negative. Okay, so what that means is in the first quadrant, all of our cosine and sine values are going to be positive. Let's start by looking at 30 degrees here. This would be 30 degrees, or pi over 6. 30 degrees or pi over 6, we're going to put the cosine value first, would be square root of 3 over 2. Where am I getting that from? Well, from that trig table that we filled out over here. Cosine of 30 degrees, square root of 3 over 2. Okay, so I'm just using those ideas to help fill this out. Sine is 1/2. Okay, but this isn't just arbitrarily putting these values here. What I'd like you to notice is this value, or this point on the unit circle, literally would have a y value of 1/2. So when we put this here, we're not just putting it there to save that, to just memorize that. It really does have a y value of 1/2 on the unit circle. The square root of 3 over 2 as an approximated value would be about 0.87, I believe. And if we actually found this x value right here, okay, if this is a value of 1 right there, that is about 0.87, or square root of 3 over 2. So the x value is square root of 3 over 2, and the y value is 1/2. All right, so the x value of all these points gives the cosine. Y value gives the sine. So I'm going to stay with that pi over 6 at 30 degrees. I'm just going to reflect this point over here. Okay, so I'm going to reflect it right across the y-axis. As a degree measure, I'm now 30 degrees short of the x-axis, which means I'm at 180 minus 30, which is 150. And as a radian measure, that would be pi over 6 short of pi, which would be 5 pi over 6. Well, if I reflect that point over the y-axis, then the y value is still going to be 1/2, but the x value is going to be the opposite, square root of 3 over 2, but negative. Okay, well, look at that matches up with exactly what we said up above. In the second quadrant, x is going to be negative, y is going to be positive. So that's not just, again, not just something that, happens to be something we need to memorize. It works because of the symmetry involved. All right, I'm going to stick with 30 degrees as a reference angle. Now we're going to go past the x-axis 30 degrees. So the reference angle we're actually putting in this spot right here, so I'm going to put that 30 degrees there. When we have a 30-degree reference angle in the third quadrant, our degrees then would be 210, 180 plus 30. Pi plus pi over 6 would be 7 pi over 6. And now my values would be, again, square root of 3 over 2, 1/2. That stays the same. Square root of 3 over 2 and 1/2 stays the same, but now they're both negative. Okay, so I'm just going to pause right here to show you why this is useful. So knowing those values, I'm not asking you to memorize this whole unit circle. Okay, I'm asking you to understand the patterns and the symmetry and the positives and negatives within it, the use of reference angles, so that you can answer questions like this. A question like, what is the cosine of 7 pi over 6? This would be a typical test question. Evaluate the cosine of 7 pi over 6. Well, you're not going to have the unit circle staring you in the face, okay? You're really not going to have anything. So what you need to know is that trig table that we've filled out already. Let me actually just do this down here. Get a blank spot. So you're asked to evaluate the cosine of 7 pi over 6 from scratch. Okay, so the first thing I would do is I would do a quick sketch and figure out where 7 pi over 6 is. Okay, so I'm pretending we didn't just work with this angle. All right, 7 pi over 6 now is just past 6 pi over 6, which is pi, by pi over 6. So in other words, the reference angle, okay, that's what we call that angle back to the x-axis, is pi over 6, and we're in the the third quadrant, which I know is negative, negative. And the negative that I'm interested in, since we're talking about cosine, not that it matters, but just in case if they were different, because they're both negative here, but that first value, that first negative sign right there is really the one I'm interested in. This tells you that our answer is going to be negative because we're talking about cosine in the third quadrant. So we know that it's going to be a negative value, And now we just need to find the cosine of its reference angle. The cosine of pi over 6, now this is where you either need to memorize these values or to be able to fill out a quick trig table, or use, if you want to, use a reference triangle. Look at that triangle that we have formed right here if I drop a perpendicular. Okay, if I drop a perpendicular back to that x-axis, I could use what's called a reference triangle, which is still using the reference angle right there of 30 degrees, or pi over 6. You could write 30 degrees if you wanted to. And since you know that's 30 degrees, we have 1, 2, square root of 3 here. And we're talking about cosine, so you'd use adjacent over hypotenuse here. Me, I just know that cosine of pi over 6 is square root of 3 over 2 because I've got those values memorized. So the cosine of 7 pi over 6 would be negative square root of 3 over 2, because it has the same value as its reference angle. That comes from the fact that its reference angle is pi over 6, and we did the cosine. That comes from the fact that cosine is negative in the third quadrant. Cosine is negative in the third quadrant. We said negative, negative, and cosine is that negative right there. So that's how you would use the idea of the unit circle. We don't actually memorize the whole thing. We just use the filling it out to help you figure out all these patterns and the connections. All right, so we're going to continue filling out here the 30-degree reference angle. So I have another one right here. That would be pi over 6 short of 2 pi, or 12 pi over 6 minus pi over 6, which is 11 pi over 6. 30 degrees short of 360 would be 330. And then we would have square root of 3 over 2 and 1/2 again. This time our negative value is just the y value, the sine value. So sine in the fourth quadrant is negative. All right, so those are the 30-degree reference angles. Now let's go through and take care of the change colors here. We're going to take care of the, let's do the 60-degree reference angles next. So I'm going to be looking at 60 degrees, or pi over 3. I'm just going to fill out the angles first. So if I were 60 degrees short, now I'm going to go into the second quadrant. 60 degrees short of 180, I'd be at 120. Pi minus pi over 3 would be 2 pi over 3. I'm going to go into this quadrant. Okay, now be careful where you're putting all these values. 60 degrees would be, as a reference angle, get me to this angle right here. So I've got my reference angle here is 60 degrees. So the actual angle in standard position, this guy here, is what I want to be putting into those values right there. Is 180 plus 60 is 240. Pi plus pi over 3 would be 4 pi over 3. Okay, and then now here's our 60-degree reference angle. Will get me that one right there. There's my 60 degrees. But the standard position angle would be 60 degrees short of 360, which would be 300 degrees. And pi, 2 pi minus pi over 3, which is 12 pi minus pi over 3, would be, no, I'm sorry, that would be 6 pi over 3. This is 6 pi over 3. That's what 2 pi is. So I'm pi over 3 short of that. I'd be at 5 pi over 3. There we go. All right, now I'm going to worry about those values. Okay, so pi over 3 is going to be these two values flipped. Because now look at my x value is at a half. My y value is at a square root of 3 over 2. And I know that the cosine of 60 is 1/2. The cosine of, or excuse me, the sine of 60 is square root of 3 over 2. And those are the same values I'm going to have going throughout the rest of the unit circle, except I just have to get my negatives and positives right. The second quadrant, the x value is negative. The third quadrant, they're both going to be negative. So I have negative 1/2, negative square root of 3 over 2. And then in the fourth quadrant, positive, negative. So we're going to have 1/2 square root of 3 over 2, but the y value is negative. All right, so again, real quick, this just tells us that for example, the sine of 5 pi over 3, the sine, I'll just write this right here, of 5 pi over 3 is negative square root of 3 over 2. Without using a calculator, we can easily evaluate that the sine function of that angle. Okay, now what if you want to do a tangent? What if I asked you for the tangent of an angle like 5 pi over 3? Okay, either you've already got it filled in your trig table, or you're using this idea of the unit circle. Remember, tangent is sine over cosine, so I could just do numerator over numerator again here. So I'd have the square root of 3 over 1, which is just the square root of 3, except now you got to remember, in the fourth quadrant, which is where 5 pi over 3 is, tangent is negative because sine and cosine are different signs. One is positive, one is negative. So our answer would actually be negative square root of 3 for the tangent of 5 pi over 3. All right, lastly here, we're going to fill out our pi over 4 values. Do those in green here. So in the first quadrant, obviously, pi over 4 and 45 degrees are the angles we're talking about. Oh, I just realized here I did not fill in my reference angle of 60 degrees in that spot right there. All right, now I feel better. Okay, now we can continue on with pi over 4. Square root of 2 over 2 and square root of 2 over 2 are going to be our values going all the way around this thing. Okay, the second quadrant, cosine is negative. What angle would this be here? Well, it's got a reference angle of 45, meaning it's 45 short of 180. Well, that would be 135 degrees. It's pi over 4 short of pi. Well, that would be 3 pi over 4. If I were pi over 4 over pi, that would be 5 pi over 4. This is a reference angle of 45. 45 past 180 would be 225 degrees. And now I'll put my cosine and sine values here. Square root of 2 for both of them, but third quadrant, they're both negative. In the fourth quadrant, our angle that has a reference angle of 45, 360 minus 45 is 315 degrees. Let's think here. 8 pi over 4, I'm going to write it right away so I don't mess it up like I did last time. Pi over 4 short of that, this can be 7 pi over 4. And that would be, let's see, square root of 2 over 2 is both my cosine and sine, except the sine value is negative. So the cosine of 7 pi over 4, for example, is positive square root of 2 over 2. The sine of 7 pi over 4 is negative square root of 2 over 2. Again, you're not going to have a unit circle. You're just going to have to answer questions like this on your quiz or on your test or on whatever, on the homework assignment. And you need to be able to use the idea of either a reference angle, reference triangle, the trig table if you want to use that, and then where things are positive, negative in order to figure out what the values are. So what I would get used to from that unit circle, more than anything, what I use the unit circle for is for these values here, so I can evaluate these quadrantal angle values pretty quickly, and just what is positive and what is negative. Get this in the right order here. Going around the unit circle. This is kind of the main idea behind the unit circle to me. I use this in conjunction with my trig table. Okay, so the trig table, you come up with the whole trig table again using the right triangles. I'm going to show you here a quick way to come up with the values in our trig table. I always go sine, cosine, and then tangent. And I'm going to just do radians here. So pi over 6, pi over 4, and then pi over 3. All right, so again, one way that I would just do this is to memorize it. Okay, it's that the sine of 30 degrees or pi over 6 is 1/2, which is the same as the cosine of 60. And then 1/2's partner in crime is the square root of 3 over 2, so that goes there and there. And then pi over 4, these are both the same, square root of 2, square root of 2. Tangent is easy to remember for pi over 4, it's just 1. And you can either memorize the tangent values, or if you don't, just take numerator over numerator in order to get what tangent is. Well, 1 over the square root of 3 would be rationalized to the square root of 3 over 3. Down at pi over 3, square root of 3 over 1 would just be square root of 3. Those are your 6 values. Excuse me, 9 values. And then you could just flip all those, use the reciprocals to get the other 3 trig functions values. So to get cosecant, secant, and cotangent. All right. Another way to quickly come up with those, just memorize them. It's easiest. But this is a cool little trick here. Is using the idea that knowing this stuff should be as easy as 1, 2, 3. Okay, you're like, what the heck's he talking about? Well, just give myself a little more space here. Remember that this is as easy as 1, 2, 3. Okay, start with that. And then I'm going to put a 1, 2, and 3 here again. All right. Then what I'm going to do is I'm going to take the square root of each of those values. All right, so the square root of 1 is 1, square root of 2 is square root of 2, square root of 3, square root of 1 is 1, square root of 2, square root of 3. So I did 1, 2, 3, and then 1, 2, 3 going back up. Took the square root of everything, and I'm going to divide everything by 2. And there's your 6 major values, sine and cosine. And then you can find tangent by doing numerator over numerator. So again, it was just going down. It was 1, 2, 3, go back up, 1, 2, 3. Take the square root of all of them, and then divide them all by 2. So you just got to remember, where these all go. It was starting from your smallest angle, 30, 45, 60, and then this was sine and cosine, and then you can find tangent by doing numerator over numerator, square root of 3 over 3 after I rationalize, 1, square root of 3 over 2. Quick way to come up with the 9 major trig values that you're going to use, and then you combine that with this idea right here, and you can evaluate any trig function going around the unit circle.